The Rowena Crest, Wasco County, Oregon. The outcrop I studied at Rowena Crest, located on the Oregon side of the Columbia River in Wasco County, about 70 miles east of Portland, 10 miles west of the Dalles, and about 30 miles north of Mount Hood. The outcrop is near the top of a cliff, at an elevation of about 700 feet. From the Rowena Plateau directly above the outcrop, you overlook the Columbia River and the Rowena Gap, the lowlands that border the river on the south side. On this south side, the hills are less steep and more covered in vegetation than on the terraced, rocky northern slope of the Washington side of the river. The rock wall of the outcrop is jagged and cracked into vertical column forms. This sheer cliff has been carved into by the highway road, meandering up to the plateau, and the rock debris is scattered below. The few square meter section of rock I focused on is at the base of one of these vertical columns of the wall. The protruding rock base is fractured and cracked and recedes as it goes up, sliding behind a slice overhang above. The rock is dark gray with reddish tints, and the surface is a smooth, aphonetic texture with no visible crystals. The history of this geological site describes the origins of this type of rock, which is mafic basalt, and the causes of the eroded landscape of the Columbia Gorge. During the Miocene epoch, fissure eruptions in the eastern Washington were active for over 11 million years, between 17 and 6 million years ago, covering a vast region of west central Idaho, northern Oregon, and Washington. These fissures are located on the western border of Oregon and Washington, but the lava floods extend all the way to the Pacific Ocean, depositing basalt an average of a kilometer thick, with areas as thick as 3 kilometers. There are around 150 separate flows that occurred throughout this time. My site, at Rowena Crest, is in the center of this Columbia River basalt group floods, designated by the pink areas on the geological map. The cause of these fissure eruptions relates to the tectonic framework of the area. These fissures are located at an ancient margin of the North American continent between the Cascade Mountain Range and the granitic Idaho batholith. The east-west tension of this boundary caused fractures and fissures in the crust, as well as bending and folding. These folds of anticlines and synclines are abundant in the Columbia River Gorge, and the Rowena Gap itself is located on an anticline where the land bulges and is flanked by the dips of the Dalles syncline and the Mosier syncline. The secondary folding between these more major folds are visible, causing faults and displacing groundwater into surface creeks at synclinal dips, such as the Klickitat River, directly across from the Rowena Crest on the north side. The second part of this story is how the deep gorge was formed, cutting through the Columbia River basalt group. This phenomenon can be explained by the glacial effects from the Ice Age. 15,000 years ago, during the last Ice Age, a lobe of the Cordilleran ice sheet dammed the Clark Fork River, forming glacial Lake Missoula in today's West Montana. When this glacial dam erupted, breaking under the pressure of the 2.5 trillion tons of lake water, the fast-flowing megaflood rushed through the landscape of eastern Washington and scoured out channels en route to the Pacific Ocean. The Columbia River surged, adding 800 feet of water. Over thousands of years, many of these megafloods erupted, gouging out the deep canyon of the Columbia River Gorge. Today, we can see the result of this magnificent sequence of events in this drastically beautiful landscape.